You know what's worse than the end of the world? Filing taxes. So here are 10 doomsday scenarios that could get you out of it. Most of them you've never heard of. All of them better than filing a 1040. And if we're lucky, at least one hits us before the IRS does. Alright, let's go. Number 1. The supervolcano that's already moving. You're thinking Yellowstone. Everyone thinks Yellowstone. But Yellowstone isn't doing anything unusual right now. The supervolcano that is doing something unusual is 8 miles wide, sits directly west of Naples, Italy, and has over 500,000 people living inside its crater. It's called Campi Flegrei, the burning fields. It was formed by 2 massive eruptions, one 39,000 years ago, one 15,000. The older one, the Campanian ignimbrite, ejected enough material to bury Europe in ash, roughly 150 times the size of Pinatubo. It last erupted in 1538. And right now, the ground beneath the city of Pozzuoli is rising. Not metaphorically, the ground is physically pushing upward, about 1.4 meters since 2005. At the old port, boats sit marooned in long grass on land that used to be underwater. The sea didn't drain, the earth came up. In 2024 alone, the caldera produced 2,500 earthquakes in a single month. Then in 2025, a team used machine learning to reanalyze 3 years of seismic data and found that traditional detection had missed most of it. The real number wasn't 12,000 earthquakes, it was over 54,000. The AI also revealed something the instruments had been too blunt to see. A sharply defined ring fault system circling the caldera, long faults, the kind that make a magnitude 5 earthquake, quote, not out of the question. The strongest earthquakes ever recorded at Campi Flegrei hit in 2024 and 2025. A 4.6 in June of 2025 cracked walls and sent people running into the streets. The director of the Naples Volcanology Observatory said it plainly. These are the strongest we've ever seen. Italy classifies the volcano as a national threat. If it erupts explosively, pyroclastic flows hit 800 degrees Celsius and move at 30 to 60 miles per hour. The eruptive column could rise 18 miles into the sky. There is an evacuation plan for the red zone. Over 500,000 people. It has never been tested at full scale. Now here's the twist. A 2025 study proposed that the thing driving all this unrest might not be rising magma at all. It might be a capped geothermal reservoir, like a sealed pressure cooker heated from below. The researchers used a mocha pot analogy. Hot fluid pushing through cracked rock. A separate study found that 20 to 40% of the carbon dioxide venting from the surface isn't even coming from magma. It's coming from heated limestone decarbonating underground. That doesn't make it safe. Steam-driven explosions can be devastating without a single drop of lava. But it changes the question from whether we can outrun it to whether we might be able to manage the pressure before it blows. One more thing. There's a town called Baia. It was a major city during the Roman Empire. It's underwater now, not from sea level rise, from bradyseism. The ground sank, empires came and went, and the volcano didn't notice. 500,000 people live inside a supervolcano that's currently producing the strongest earthquakes in its recorded history. And the boats at the port are sitting in grass because the ground rose out of the sea. But sure, worry about Yellowstone. Number 2. The tree rings that recorded something worse. You've probably heard of the Carrington event, 1859, biggest solar storm in modern history. Telegraph operators got shocked, machines caught fire, gold miners in the Rockies woke up and started making breakfast because the auroras were so bright they thought it was morning. It's a great story. It's also the small one. Carved into tree rings around the world is evidence of something 10 to 100 times worse. They're called Miyake events, named after Fusa Miyake, who found the first one in 2012 buried inside Japanese cedar trees. What she found was a radiocarbon spike dating to 774 CE, a fingerprint of a particle bombardment roughly 20 times normal solar variation, more than 10 times the Carrington event. And it's not alone. Another spike at 993 CE, another around 7,176 BCE that may have been even stronger. They show up in tree rings and ice cores going back 14,000 years. The pattern says they happen roughly once every 500 to 2,400 years. The last confirmed one was about 1,000 years ago. You're inside the window. A study scanned over 56,000 sun-like stars and found nearly 3,000 superflare events, stars of the same spectral type as ours, doing this routinely. The debate is whether our sun specifically can produce one. Some researchers say its slow rotation makes it unlikely. The tree rings say it already has, multiple times. If a Miyake scale event hit today, it wouldn't just disrupt satellites, it would physically destroy them. The energetic particles from a flare like this travel at near light speed. That gives you about 8 minutes of warning, not 8 minutes before the grid goes down. 8 minutes before the particles start hitting the atmosphere. Ground level radiation at high latitudes comparable to several chest x-rays for anyone standing outside. Here's the part that haunts researchers. When the 774 event was first discovered, nobody knew what caused it. The leading theories were a nearby gamma ray burst and a supernova. It took years of additional isotope analysis to confirm it came from the sun. Something catastrophic happened in the sky during the Dark Ages, bright enough to leave a chemical scar in every living tree on the planet, and there is almost no historical record of anyone looking up and noticing. The Carrington event is the famous one, but the tree rings remember worse, and the trees don't exaggerate. Number 3, the prison of our own making. Every other entry on this list is something that happens to you. A volcano, a solar storm, an ocean turning toxic. This one you're building yourself. In 1978, a NASA scientist named Donald Kessler proposed something simple. If you put enough objects in low Earth orbit, eventually 2 of them collide. That collision produces debris. That debris hits other objects. Those collisions produce more debris. And at some point, the cascade becomes self-sustaining. A chain reaction of shrapnel, turning orbit into a blender. Right now, there are about 13,000 tracked objects larger than 10 centimeters up there. Estimated fragments between 1 millimeter and 1 centimeter, 130 million. Active satellites, over 7,000, roughly double what it was in 2020. Most of the growth is Starlink. Collision speed in low Earth orbit is about 10 kilometers per second. At that velocity, a fragment the size of a marble carries the energy of a hand grenade. A paint flake can crack a window. That's not hypothetical. Paint flakes cracked space shuttle windows multiple times. In 2009, 2 intact satellites collided for the first time ever. Iridium 33 and Cosmos 2251 hit each other at nearly 12 kilometers per second and produced over 2,000 trackable debris fragments. In 2021, Russia blew up one of its own satellites in an anti-satellite weapons test. 1,500 new fragments. The crew on the International Space Station had to shelter in their return vehicles. China did the same thing in 2007 and created 3,500 fragments that are still in orbit today. Full Kessler syndrome wouldn't kill anyone directly. What it would kill is everything that depends on orbit. GPS, weather satellites, communication networks, hurricane tracking, precision agriculture, financial transaction timing, human spaceflight, gone for potentially centuries. And here's the one that should keep you up at night. Asteroid deflection missions. You can't launch a planetary defense spacecraft through a debris field. Kessler syndrome would lock humanity on Earth during the exact window in history when we're developing the ability to leave it. The only doomsday scenario on this list where the weapon is a paint flake traveling at 10 kilometers per second, and we're the ones putting it there. Number 4, 2,000 transformers. You know what a solar storm does. This is about why recovery takes a decade instead of a week, and the answer is embarrassingly specific. The entire electrical grid of the United States depends on roughly 2,000 extra high voltage transformers. The big ones, 345 kilovolts and above. Each one weighs 100 to 400 tons. Each one costs $3 to $10 million. Each one takes 12 to 24 months to manufacture, mostly overseas, mostly custom built. There is no strategic reserve. A few dozen spares exist across the country, and most of them aren't compatible with each other. They can't be moved by normal trucks. They require specialized rail cars. Fewer than 40 of those rail cars exist in the entire United States. A 2025 study mapped what the ground-level electric fields would look like during a major geomagnetic storm. The worst zones are the eastern and midwestern US because the bedrock there is more electrically resistive, which amplifies the induced currents. That happens to be exactly where the largest population centers and most critical infrastructure sit. When those transformers overheat and fail, they don't trip a breaker. They melt, and once they're gone, the cascade starts. Water treatment loses power within days. Fuel pumps stop. Hospitals burn through their 72-hour diesel reserves. The food cold chain breaks. Cell towers have 8-hour battery backups, then silence. Financial systems go offline entirely. Research estimates suggest a 38 to 48% reduction in global agricultural yields from the cascading infrastructure failure alone. Some regions lose up to 75%. Recovery estimate a decade. Cost trillions. The UK's 2025 National Risk Register rated severe space weather at a 5 to 25% likelihood within the next 10 years. The entire eastern seaboard's continued existence depends on about 2,000 machines that weigh as much as a blue whale and take 2 years to build. And there's no backup. Number 5, when the seafloor exhales. There's more carbon locked under the ocean floor right now than in all the coal, oil, and natural gas on Earth combined. It's sitting in ice-like structures called methane clathrates, methane molecules trapped inside crystal lattices of water ice, stable as long as the pressure stays high and the temperature stays low. Estimated deposits, 1,000 to 5,000 gigatons of carbon. If just 1% of that releases as methane, atmospheric methane roughly doubles. And methane is about 80 times more potent than carbon dioxide as a greenhouse gas over 20 years. The clathrate gun hypothesis, proposed in 2003, describes the nightmare version. Warming oceans cross a threshold. Clathrates destabilize. Methane floods the atmosphere. That methane causes more warming. More warming destabilizes more clathrates. Runaway loop, no off switch. This has happened before. 56 million years ago, during a period called the Paleocene-Eocene thermal maximum, global temperatures rose 5 to 8 degrees over about 20,000 years. Ocean surfaces in some regions hit 36 degrees Celsius. Basically a hot tub. The leading candidate for where all that carbon came from is seafloor methane. It took 200,000 years for the climate to recover. Right now, in Siberia, craters up to 50 meters wide are appearing. Methane blowouts from thawing permafrost, punching holes in the earth. Arctic lakes are bubbling with methane so aggressively that researchers light the bubbles on fire for footage. Atmospheric methane concentrations have been climbing faster than expected since 2020, and nobody has fully accounted for the source. Now, the honest cut. Most climate scientists consider the full gun scenario, a rapid catastrophic release, unlikely in the near term. Clathrate destabilization would probably play out over centuries to millennia, not decades, but the permafrost thaw is outpacing the models, and the fossil record proves the mechanism works. It's not a question of whether the seafloor can exhale. It already did once. The planet spent 200,000 years coughing. Number 6, the green sky. The ocean is losing oxygen. Not dramatically, not visibly. About 2% globally since 1960. Marine dead zones have quadrupled since the 1950s. The Gulf of Mexico dead zone covers 6,000 to 7,000 square miles every year. None of this makes headlines because it's slow and it's invisible and nothing about it looks like the apocalypse. But the geological record knows what this looks like when it finishes. An ocean anoxic event. The water warms. Warmer water holds less dissolved oxygen. Nutrient runoff feeds algal blooms. The algae die and decompose, consuming whatever oxygen is left. Warm water sits on top of cold water like a lid, preventing mixing. Layer by layer, the ocean suffocates. The worst version of this killed more species than the asteroid that killed the dinosaurs. The Permian-Triassic extinction, 252 million years ago. 90 to 96% of all marine species gone. The mechanism wasn't an impact, it was the ocean dying from the inside. Volcanic carbon dioxide from the Siberian traps warmed the water, collapsed oxygen levels, and then something worse started happening. Paleontologist Peter Ward described the endgame. Once the deep ocean goes fully anoxic, a different kind of bacteria takes over. Purple and green sulfur bacteria that thrive without oxygen and produce hydrogen sulfide as waste. That gas rises from the ocean into the atmosphere. It poisons land animals. It destroys the ozone layer. And it turns the sky green. Not poetically. The chemistry of hydrogen sulfide in the upper atmosphere literally shifts the color of the sky. You know the smell. Rotten eggs. That's hydrogen sulfide at low concentrations. At high concentrations, you can't smell it anymore. It deadens the olfactory nerve before it kills you. The Permian extinction didn't need a rock from space. It just needed the ocean to stop breathing. And right now, measured, mapped, the ocean is losing oxygen a little more each year. This is the slowest entry on this list. It might also be the deadliest. Number 7. The wave with no earthquake. Tsunamis need earthquakes, that's the rule. Except when a volcano's entire flank slides into the ocean. Cumbre Vieja is a volcanic ridge on La Palma in the Canary Islands. It last erupted in 2021. In 2001, 2 researchers published a model showing that a future eruption could collapse the western flank of the volcano, dropping up to 500 cubic kilometers of rock into the Atlantic in a single event. Their model predicted waves 900 meters high near the island, 10 to 25 meters hitting the US East Coast 6 to 9 hours later. That model has been heavily contested. Multiple follow-up studies argue the collapse wouldn't happen as a single block. It would break apart gradually, smaller slides over hours or days or years. Revised estimates for the US East Coast put the waves at 1 to 3 meters. Still dangerous for coastal flooding, not civilization ending. But here's the thing, the revisions don't erase. The geological record around the Canary Islands is littered with debris fields from past collapses. The Guimar and Orotava landslides on Tenerife moved about 1,000 cubic kilometers of material into the sea. These megaslides have happened. The seafloor has the scars to prove it, and there's a precedent from elsewhere. About 8,150 years ago, a submarine landslide off Norway called the Storegga Slide displaced 3,500 cubic kilometers of sediment. It generated tsunamis up to 25 meters high that hit Scotland, Norway, and Iceland. Some researchers think it helped drown Doggerland, the land bridge that once connected Britain to mainland Europe. The 2021 eruption of Cumbre Vieja didn't trigger a flank collapse, but it deposited fresh lava on the western slope. Added weight to an already unstable structure. Each eruption nudges the odds. The question isn't whether it's possible. The scars on the ocean floor settled that. The question is whether the next one comes as a single catastrophic block or a slow crumble. And how much of a difference that makes if you live on the Atlantic coast. Number 8. The drill we already failed. COVID-19 had an R0 of about 2 to 3, a case fatality rate well under 1% globally. And it shut down the world economy, overwhelmed hospitals on multiple continents, and killed millions. Now imagine the parameters go up, even modestly. The World Health Organization has a placeholder on its priority disease list called Disease X. It's been there since 2018. It represents a pathogen that hasn't infected humans yet, but could cause a pandemic. Estimates suggest there are roughly 1.7 million undiscovered viruses in mammals and birds. Between 630,000 and 827,000 of them may have the ability to infect humans. The interval between major pandemics has been shrinking. 1918, 1957, 1968, 2009, 2019. Each gap shorter than the last. And right now, H5N1 avian influenza has been circulating in US dairy cattle since 2024 with sporadic human cases. The global case fatality rate for H5N1 in humans is around 50%. That number is almost certainly inflated by detection bias toward the sickest patients, but the number exists. and it sits in the back of every epidemiologist's mind like a low hum. The worst-case combination isn't exotic, it's mundane parameters stacked. Airborne transmission with an R0 like measles, 12 to 18. A case fatality rate of just 5 to 10%, not 50. A long pre-symptomatic infectious window, resistance to existing treatments. You don't need a science fiction pathogen, you just need a natural one that rolls the right combination of ordinary traits. COVID was the open book exam, and the honest assessment is that we didn't pass. The infrastructure buckled under a pathogen that was, by historical standards, relatively mild. The next one doesn't have to be dramatically worse to be catastrophic, it just has to be a little worse in the right ways. Number 9, the explosion nobody talks about. Classical novae are tracked, supernovae are tracked. There's an entire category of stellar explosion happening across the galaxy that nobody knew existed until 2022 because each one is over in a few hours. They're called micronovae, first identified and published in Nature in April 2022. They occur on white dwarfs, the dense remnants of dead stars roughly the mass of the Sun compressed to the size of Earth. When a white dwarf with a strong magnetic field sits in a binary system, it steals hydrogen from its companion star. That hydrogen funnels down to the magnetic poles and detonates locally, not across the whole surface like a classical nova, just at the poles. Microfusion bombs, about 1/1,000,000th the strength of a full nova, burning through about 3.5 billion Great Pyramids of Giza worth of material in hours. White dwarfs are the most common stellar remnants in the galaxy, billions of them, many in binary systems. The nearest known white dwarf is Sirius B, 8.6 light-years away, orbiting in a binary with the brightest star in your sky. The researchers who discovered micronovae said it plainly. These events may be extremely common, they were just too fast to catch until space telescope data made it possible to look for them. Here's the question that sits underneath the discovery. If there was an entire category of stellar explosion happening all around us that we only just noticed, what else is out there detonating on timescales too short for our instruments? The catalogue of things that explode in space was incomplete until 3 years ago. Nobody can tell you with confidence that it's complete now. Number 10. Everyone's afraid of the wrong thing. Yellowstone, the supervolcano. You've seen the videos, the simulations, the dramatic maps showing ash covering the entire continental United States. It gets millions of clicks, and it's the single most overhyped geological threat on the internet. The USGS has said, repeatedly, that another super eruption is not imminent, probably not for millions of years. The magma beneath Yellowstone isn't even in a state that could erupt right now. But Yellowstone does have a real threat, one that could happen tomorrow, and almost nobody covers it because it doesn't have the word super in front of it. Hydrothermal explosions, superheated water sitting in reservoirs underground, held liquid by pressure. If the pressure seal breaks, earthquake, erosion, anything, that water flashes to steam instantaneously. The result is a violent explosion that can create craters up to 1 kilometer wide. No magma required. Over 20 large hydrothermal explosion craters have formed in Yellowstone in the last 14,000 years. Mary Bay on Yellowstone Lake is 2.6 by 2.4 kilometers. It formed about 13,000 years ago. Indian Pond formed around 1300 BCE. This is not ancient history, this is recent, and it's recurring. In July 2024, a hydrothermal explosion went off at Biscuit Basin in Yellowstone. Boiling water, rocks, and debris launched into the air right next to a boardwalk where tourists had been walking minutes earlier. The boardwalk was destroyed. The area was closed indefinitely. Yellowstone gets about 4 million visitors a year. Many of its most famous geothermal features are steps away from developed paths. A Mary Bay scale explosion today, with no warning, near a populated area would be catastrophic. And unlike the supervolcano, which is millions of years away from doing anything, hydrothermal explosions can happen anytime. With minimal warning, the mechanism is active. The 2024 event proved it. Everyone's afraid of the supervolcano. The USGS is afraid of the steam vents. That's been the pattern the entire time. Every threat on this list has a famous version and a quiet version. The famous one gets the clicks. The quiet one is the one actually ticking. It's written in tree rings and transformer logistics and ocean chemistry and boats sitting in grass where the sea used to be. The doomsday scenarios that matter most aren't the ones that sound the scariest. They're the ones that are already moving while everyone's looking the other way.